First of all, another visitor from abroad, Gavin Wells, and out of respect for the audience, the very knowledgeable South African audience, and in a very London way, put a time on.
We want to do the same.
Thank you very much.
Pleasure.
All yours.
Thank you. Financial services, I think, can gain a lot from what Bitcoin and blockchain has shown the world. It's a vast topic. I'm only going to talk about financial services, and I know that creates certain emotions in certain people. But that's what I was asked to speak to, and that's what I will speak to. So my name's Gavin Wells. I work at Digital Asset. I am blessed in that throughout my life I have seen continual innovation getting bigger and bigger all the time. The first 8 years of my life I was in the army, and we used to load very big metal shells into guns. 4 people would pick a piece of metal up, and we'd throw it with lots of gunpowder, 30 miles or so, and it would land vaguely near the bad guys, probably not too close to them, and this big lump of metal would make a big hole in the sand. And over 8 years, we developed that into something which rained down, a bit like a Hoover, 7,000 bombs in a 300 by 300 meter square, and it was like hoovering up the bad guys. You just cleaned the air, and we used that in the first Gulf War. So the speed of innovation, relatively slow, but quite impressive. I then went into banking, and we started out with people using pens and paper, and by the end, I was running algorithmic trading, and the only reason you had a human, you also had a dog, the joke that the dog was there to keep the human from touching the computer that did all the trading. So banking saw a great deal of innovation from the mid-90s through to the 2000s. And I left just before Lehman's and joined a clearinghouse just in time to watch Lehman's. And I have to say, for all you may read in the press, we got the market got through that by the skin of our teeth because we didn't really know the positions. And if you're in Canary Wharf or in New York, everyone was leaving Lehman's, obviously. People were selling their cars for a song. You could buy a Ferrari for 20 or 30,000 pounds. But everyone was leaving, and no one could get the data to know what positions they had or to confirm them. So we had to pay people to go back into Lehman's to switch the computers on to tell us and confirm that. So this operational reconciliation you heard about earlier from Clive, because of that, lots of regulation clearly, but great innovation in the way that we manage data and in the way that we're safer. Things like capital and netting of risk. And we'll come on to that now. So I left clearing and came into distributed ledger technology. I'm not going to say Bitcoin and I'm not going to say blockchain because I think of it as DLT doesn't offend anybody. It's too generic, so no misuse of the word. And the way I'm going to talk about why it's important for innovation in financial services is to give you a brief overview of digital assets so you know who we are. Then talk to why we've designed something the way we have because we think that's what's needed for financial services to innovate. And then give you some real use cases, 3 clients we're working with and the opportunities they see. And then I'll outline about 8 use cases where the clients are not in the public domain, so I'll talk to the use case and not the client. So we are a software company. We build distributed, encrypted, straight-through processing tools based on distributed ledger technology. Why do we do that? Aside from the fact that the CIO or CTO of every bank and every financial market infrastructure has to have a blockchain strategy written on their whiteboard, which is true. The banks have been suffering since 2008. Revenues have dropped. Look at their share prices. The cost of operating has gone up due to complying with regulation, and capital has to be held in ever greater measure. So very often the cost of the capital is greater than the return on equity, so they're losing. As a direct example, I got most of my pay as an overpaid evil banker, citing the earlier panels, in Citigroup stock that's currently worth 10% of what it was in 2008 when I was given it. It's never going to get back. The banks are suffering and they need something. So that's why we do what we do. Thank you very much. This is who does it. And the reason I show this is that this is really complicated. Whenever anyone says, I'll explain this non-technically, I think that's a lie. You can't explain technology non-technically. It's degrees of technical explanation. So we have a non-technical white paper I'll talk about at the end, which is really hard to read if you don't understand technology, but it's less hard to read than our other white paper that's technical. So this group of people who are the leadership team of DA, Blythe, some of you may know, top left corner, 30 years at JP Morgan. She gets business, and the whole point is many of our clients are financial market infrastructure, And we need to understand how they work and what their drivers are. Same with Chris Nexter, he ran Swift in North America. Then skip along to Shaul, he's the co-author of LibSnark, one of the zero-knowledge proofs, having been in the Israeli army for quite a while. Around him, on either side, you've Alan Eric, you've got two ex-proprietary traders, one traded Bitcoin, one did high-frequency trading for a very big fund in the States. And then Dan, on the far right, was the CEO of Hyperledger, one of our acquisitions. And at the bottom, varying levels of expertise. But Kelly and I, on the two extremes, we do a lot together. She's had 30 years at JP Morgan running collateral and security services, and I've been in the currency markets most of my life. So the idea is we're the bridge between technology and business. We understand the business, and we've got enough engineers to help us with the technology. So that's the people. We needed to get some money to operate. A year ago, we raised 70 million. We didn't want one voice. As you'll see when I talk about open sourcing, no one can own this, and therefore no one should shape it. So Blythe was very clear. We wanted financial market infrastructure. We got some from all over the world, the ASX, the DTCC and the CME from the States, and the Deutsche Börse Group from Europe, all pretty big players. We had to have a few banks, obviously, some from Europe, some from America, but banks tend to be pretty international. So 5 or 6 of them. We needed some professional services partners, so Broadridge and Accenture. We needed some heavy IT, also as a strategic partnership, so we got IBM. And ICAP, a broker, so a healthy mix of investors in the firm. Now, some of those, when you as a startup, we needed to be able to reach out and to scale our operations. So this lot help us with things like gathering business requirements, agreeing use cases, integration, and implementation. Clearly, there's some competitive pressure. You'll all know that IBM is one of the main drivers of the Hyperledger project and of Fabric. But it's, as a few have alluded to already today, there's perhaps more collaboration than competition. There is still some competition, but we work well together. So we had the right group of people. We had a whole bunch of cash. We had some good strategic partners. Then we needed to buy some brains. As you know, the leaders of the firm don't always have all the brains. So we bought these 4 companies a year ago. The one at the top, Elevance, they're in Zurich, and they've created a domain-specific language that I'll talk about a bit later, known as DAML. It's the thing most people who know us want to talk about. The other 3 technology companies in varying stages of ledger definition, and we gave, believing in open source, we gave the Hyperledger name and much of the code to the Hyperledger project. So we're firmly of the belief that this should be democratized or socialized, not quite in the way that the 2 words I said I won't say imply, but open sourcing is important. So we're a founding member of this, and Blythe chairs the governing board until I think her first anniversary in April. Dan from Hyperledger is the marketing committee, and Tamas, who is the CEO of one of the other companies we bought, is on the tech steering committee. So we're very supportive of open source. But at the same time, the product I'll talk about in a moment is built on our own technology for now. So we believe in open sourcing, but it's not ready yet. And as a result of all that, this is where we have offices. Typically set up to be with our clients, the team down in Sydney, you'll hear about that client. In Zurich, you'll hear about that client. And then New York, Budapest, and London. Okay, so that's digital asset. 80 people at the moment. We were 20 a year ago. We'll be about 150 by the end of this year. Let's talk about why distributed ledger technology is important for innovation in financial services. I wouldn't have thought I really need to convince you all, as you've all turned up today, but some of the thought processes we went through. The technology is not a panacea for all ills. You need to separate reality from hype in the financial services frame. There are things that are very good outside that group of users, but they're not good within it. So you have to recognize that you can create risk as well as mitigate it. And the obvious things are you need to know your clients in financial services and have great control over them. You have very strict rules on what you can and can't do with your data. Scale, we know the volume of financial transactions for a second wouldn't cut it. On the other hand, we don't need 70,000 like Visa either. We know that the financial markets, especially since '08, continually have to prove to their regulators that they're resilient, that they're managing their systemic risk, and a permissionless blockchain didn't do that. Smart contracts. This is reminiscent of 1987, I thought, and the close-coupled algorithms that caused the stock markets to crash. The huge joy, because as human beings, we're inevitably lazy. We always want more for less and things done for us so we can have more time to develop more things that do things for us. So smart contracts I watched last summer as they very quickly, after the Dow, went from being smart contracts to simple contracts and then to Ricardian contracts, which I gather, as many of you will know better than me, goes back some 20 years. But it was clear that smart contracts in their form weren't right for financial services, although the idea was good. And we knew that banks needed to develop, but they hadn't got much money, and so they needed to mutualize. They needed to share cost. So we realized that you can't have a permissionless network. Most of us know that by now. Encryption. We knew that even if you encrypt data, the way financial services guard their data, that isn't enough. So you probably have to segregate it. We knew that pseudonymity or anonymity weren't good enough. Look at what Denmark and the US have done in tracing criminals, the few criminals who use Bitcoin. But you can trace through pseudonymity the identity of someone. That wouldn't work for financial services. So obfuscation wasn't enough. Multi-right is good for a democratic solution, but when you look at the regulators' stance, bringing new technology to the markets, the regulators like to have one person who can be to blame, one person who they can hold accountable, one person who runs everything. So actually, multi-writers for financial services wasn't so relevant, and of course with multi-writers, you open yourself to cyber attacks as you expand the attack vectors. So we need to think about whether or not multi-writer solutions were needed. And as I've said on smart contracts, you have to be absolutely certain of everything that's going to happen. You cannot have unintended outcomes anymore in finance. So we set some rules, and these were our architectural goals and principles, which will be pretty straightforward. Once you see them, it's motherhood and apple pie. We know that everyone in financial services has to keep a copy of their own data. And so we know that that data would have to be reconciled to the master copy on the ledger. We also know that that data and any logical processes around it has to be confidential. And all of that has to be updated the whole time. Must be great continuous data integrity. We knew that stakeholders to data should be able to get meaningful real-time analysis. That's what the trade repositories should have provided, but they haven't. There's so much data, you don't know where you're looking. As a regulator, for example, you should be able to resolve a security with such granularity you can get to the ultimate beneficial owner. We knew that there are emerging opportunities, or you could say lifelines. Financial services has changed forever. And so new opportunities for business and services have to be developed relatively quickly, but there isn't that much development money to do it. So whatever you do, if it's a system which mutualizes that cost by mutualized participation, that helps people come to market quicker. That would support innovation. We knew we had to segregate data, more of that in a moment. We knew that code had to be subordinate to law. So it's going to be a many, many year migration of this technology going into financial services. And the idea that code can be law, we don't hold. That may change, but for now we don't. So code should be subordinate to the law of the region or jurisdiction, market practices and guidelines, and any bilateral agreements that you hold between you as participants in financial services. So it must fit with existing market practices. It can't just work with today's technology. If this is going to enable innovation, it must be sufficiently flexible to work with tomorrow's technology, be open. It must also be sufficiently flexible to change roles, because we don't believe that this will disintermediate banks or CCPs or CSDs, but their roles will change. And so what you build has to be flexible enough to move with that. And finally, we recognize that in the life cycle of many assets, you can have many parties involved, not just the two stakeholders who started the transaction. So you've got to be able to distribute the execution of those actions during the life cycle safely and securely. So we applied those, and we went from that, the problems, to what we thought we had to have, which was this. You need a permission network for financial services. My mum knows that, so I'd expect you all do by now. You can use a ledger for some things like synchronizing events, notifications, but it's cryptographically hashed, the data on the ledger that all see. And the confidential data, the nature of the transactions, is stored in private stores. I'll show you a picture of that in a moment. In making a gentle approach to these very heavily regulated markets, you start with a single writer, a trusted entity already known to the regulators. I know that goes against many of the themes of the 2Bs, but it's how you start in financial services. And that gives you capacity, and capacity at something like between 800 and 1,000 transactions a second, which is sufficient for financial services. With a single writer, they have to run multiple instances, so they have resiliency, and of course they can then recreate the entire network, but any participant running a node can recreate their own segment of the network, so you enhance resiliency. Smart contracts, you have a domain-specific language that's non-Turing complete, so it's mathematically analyzable to produce finite outcomes. I can say that in English again when I get to that slide. And finally, you can't make a big change in the markets. It's got to be iterative. So not everyone has to move to it. And many market participants access the markets today through a bank or an agent or a CCP or a CSD. So there must be someone who market participants can access this through so they don't have to change until they're ready. So iterative adoption. So this is a solution that we have been building for financial services that we will start to deliver into the real world later this year. So what does it look like? Let's start at the bottom. Our ledger is split in two. And this is to get around data privacy and confidentiality issues. So for those really interested, on the 8th of November, we issued a white paper on the global synchronization log to the Linux Foundation. It's only about 9 pages long. What it says is that we store fingerprints, hashes of the data on the ledger, and these notify the stakeholders in the network to the fact an event has occurred by the hash. That's through them both maintaining their own public and private keys, and the shared secret they create is what identifies the hash to them. The confidential data is stored in their own private contract stores, their own databases, so no one can ever get to it but them. However, the market operator has a master copy of all data so that the market operator, the person in the center, and the regulator can see everything. So everyone can see the log, and then only you can see your confidential data. Now, if you want to prove the hash on the log, on the ledger, you just rerun the model on the confidential data in your contract store to recreate the hash and compare the two. So that's the basis of our platform. And when we talk about open sourcing, the reason we issued our white paper on the global synchronization log was to tell everyone what we were thinking of doing. And since then, Richard at R3 has commented he likes it and will take some bits of that into Corda, and IBM and Fabric are still thinking about it. But this is an example of collaboration. We will learn from them in the same way. The bit that sits on top of that, the smart bit, the secret sauce, is DAML. DAML is a domain-specific language. It's Haskell-based. It's a functional programming language. It is not Turing complete. So the English version, the way I explain to my son what I do. We're all greedy. We all want more for less all the time. So computer coding, programming languages have become ever broader, more infinite in their scale in what they can do. That means in a typical software development, when I was in the clearinghouse, you build something, and then you test it, and you test it, and you test it, and you test it with your members, and the regulators say yes, and you release it, and you get bugs. And why do you still get bugs? You get bugs because the language you're using is so powerful that to test it for every possible outcome is too complex. So you go backwards a step and you take a deliberately restricted language where you can prove the outcomes. And because you can prove the outcomes of the language, then you have no unintended consequences. So we've built DAML to model both the rules of the operator or the market and to model the contractual obligations that take place between two people in financial services. We've built it to be able to analyze the parties to a trade, so only those people get to see the confidential data. We've built it to be extensible because it's in libraries. Libraries are by asset class or by functionality. There's an equity library and a repo library. There's a client identity library. So it grows, and the longer you wait, the more there is to choose from. We've talked about its ability to analyze itself. Intuitive for business users, I can read DAML. The last time I looked, I can't read C++. I'm not very good at Java. It's not quite like Ricardian contracts where it's prose, but it's still logical enough that you can read it as a business user. And the built-in safeguards, it's built within a framework such that once the rules are in place, once you've built the rule book of that market, you then cannot write lines of code that break the rules. That's DAML. We spent 3 years building it. Comes from the acquisition 11th. Blythe has said she will open source it once our product is complete and deployed, which will probably be at the end of this year, and it'll be open source through the Linux Foundation. So this maintains our view of democratizing what you have. This is our stack. I did like Adrian's stack. I've never seen the internet shown so eloquently and simply. I didn't know that's how it worked. Very good. This is our stack. And it's designed to be generic. It's designed to be a ledger at the bottom in 2 parts. And when other ledgers come to market, if our clients want us to use Fabric or Corda or other, then if we can use those, we will. But for now, there isn't one, and we're going live this year, so we have our own ledger. On top of that sits an execution engine, which runs the models that are in DAML. So all the blue boxes, pale blue boxes, are our product as a software company. Then the platform API connects to your applications, and it takes messages in a number of formats. It will, at the moment, it's a proprietary format and fix. It will take Swift, MQ, ISO 20022, and anything that a client wants. We can build to any format. So the idea is you keep using your applications as today, your GUI or your system, it feeds the business messages that we then adapt so that the models can validate that business message against the rulebook. If the models are happy, they then cryptographically hash and commit that to the ledger, and they then populate the private contract stores of each participant with the contract details. Simple, really. I'm not going to go through that again, but you can ask me at the end if you want that slower. So therefore, it scales horizontally because you just deploy different stacks. And the idea of the deployment you'll see in a moment is that the market operator runs one of these to write, and others run the same stack to sign and read. What do I mean by that? Well, we see 3 actions on the product we're building. You can read what's on the ledger, and that's probably what a regulator is going to want to do. And the regulator can access the entire store of contractual information, run the models on them to produce hashes to validate what's on the ledger, but they can see everything. Signing is what market participants do when they commit, authenticate, and authorize a trade to the central operator or the single writer of the market. Once that person has written, committed to the ledger, then the participant, the signer, also reads the ledger to make sure it's good. And then the writer, single writer for the moment, they're the only one who touches the ledger. So these are the 3 actions, which will be split into 2 roles, which look like this. To start, it will be, and I know I'll get bricks from Bitcoin and blockchain fanatics, that the one on the left is nothing like distributed. Deliberately so. It's the soft approach into these really complex financial markets. It's how you start. Once the operator is running it and the users get used to it through the operator, the users then run their own nodes. That's the second picture, where their nodes are signing and reading, but not writing. Once we, or the market, comes up with a consensus mechanism for private networks, and we don't think zero-knowledge proofs are ready for that yet, and you have to be aware of the implicit increased cyber threat. But once that happens, then the third diagram comes into play, and you have multiple writers on the network and multiple participants running nodes. But we start with the first one and move to the second. That's the deployment plan for the clients that we're working with. So that's the company. That's the technology we've built. We think distributed ledger technology is therefore innovative for financial services because you've heard about reconciliation from Clive. I won't go over that again. We recognize the importance of smart contracts and building business logic into templates such that you agree all future life cycle events, you pre-authorize them. We recognize the opportunities this brings, both in saving money and saving capital, as you'll hear about in one of the use cases, and therefore in innovating, perhaps to survive. So the opportunities, what does this bring? The most popular use case is the Australian Equity Exchange. CHESS currently runs clearing and settlement in Australia for all the Australian equities market. And just over a year ago, the ASX decided they wanted to replace CHESS, and they looked at a number of technologies, one of which was distributed ledger with us. They gave us 6 or 8 months to prove the technical feasibility, scalability and resiliency, and we did that. So in June last year, they examined it with their regulators, the RBA, ASIC, the tax authorities, and being happy, they instructed us to go ahead and build an industrial-grade solution for the clearing and settlement of all the equity markets in Australia. I say all the equity markets, there is only one right now. So we're building that with the ASX. Now, the reason the regulators want it is because they think this will enable competition. Because once it's built and implemented, and once you have a multi-writer solution, then users of the equity markets can choose to execute on different exchanges who will use the same infrastructure, and it'll be simpler for the end user. The ASX know this is coming, so they're enabling competition because that's what you have to do under the regulation. So that's the shiny use case everyone thinks of when they talk about us, but the astute of you will have noticed a press release on Monday. I'd love to say it was timed for me to come here, but that would be a little bit too much. The DTCC. So they announced on Monday that the proof of concept we did on netting US Treasury repos has given them real-time information sharing that lowers the risks and costs and increases the liquidity. What does that really mean? The US Treasury repo market, the way that people fund themselves, the way they borrow money short-term, is about me lending you an asset and you giving me cash for 1, 2, 3, 5, 10 days. And all of that is cleared through a CCP known as the FICC within the DTCC. More acronyms to come. Since the bad days of 2008, if I do a transaction with you in the market as a participant, I hold anything between 10 and 15% of that in capital against the threat of you running away and not honouring your obligations. But if I do that trade in a central counterparty, I only hold 2%. Big difference. Okay, so far so good. So the repo market's really big, $3 trillion a day. And lots of people are not very organised, so they do repos value today until a future date. Well, the problem with processes in finance, as many have alluded to today, is they're quite inefficient. So I do 100 million today, I lend you an asset today for 100 million, I'm going to get it back tomorrow. The tomorrow bit we clear, because it's tomorrow, there's time to run a batch tonight, to capture it, to process it, so I pay 2% capital. But the today bit can't be captured, so we do it bilaterally. Now, we not only have to keep both legs separate, 2 $100 million trades, but I also have to pay 15% capital for today's trade. That is a huge amount of money, of capital held against these trades, and inefficiencies and risk. So by being able to confirm the data much quicker from capture, you can actually net today's trades against the existing portfolio and reduce huge amounts of capital. So it saves a lot of cash. So Mike Bodson at DTCC has said that they're happy with the POC. They're now going to a stakeholder engagement, just as the ASX did, to see if their members want it. If their members want it, and they'll decide in around June this year, then they'll move into a development phase. So Australia is about more efficiency in clearing and settlement of equities and about fostering competition. This is about saving capital and bringing efficiencies. The third one is SIX. For those who don't know SIX, SIX are the exchange group based in Switzerland who run everything in Switzerland, from a bond being issued by the government through to the operation of the Swiss franc, all the way through to the ATM machines and the swipe card machines in the grocery stores. They run everything. They run the entire Swiss value chain. Much like some of the people here from Straight, they have been looking at this for several years in detail. And about 9 months ago, they chose us to be their, another acronym coming, DLTP, Distributed Ledger Technology Partner. And they asked us to build a prototype, and we looked at securities lifecycle, the issuance of a bond and the auction of the bond in a primary market, and then banks trading that bond in the secondary market or over the counter. Then the application by the issuer of corporate actions like redemptions and coupons. And we built that on the ledger as a prototype, demonstrated it to the Swiss National Bank, to their regulator FINMA, to all of the SIX group, and at the same time we wrote a roadmap for them covering the entire Swiss value chain, showing where we saw there were things that could be made more efficient. Now we get approached, we're very blessed, we get approached by a lot of people who want a blockchain. 2 or 3 entities a week come and ask us for a blockchain for their business. And most of them we explain why they don't need it yet. And that the best way to understand the technology and get ready for it is to engage with someone like the DTCC or the ASX's working group or many others. So with SIX, the things we proposed in the roadmap are where there is real efficiencies to be had. And they're now deciding what they will do with that. So that's the third opportunity. In this case, it's securities lifecycle processing, and particularly corporate actions. I didn't know that some corporate actions for small issuers are issued in the local newspaper. So if you own a bond and you don't subscribe to the local newspaper of that region, you don't know that there's been an action on the bond that you hold. That seems quite a long way behind where you'd hope financial services would be. So the things which have no names to, the other use cases we're looking at, well, everyone has said client identity. It's really client onboarding identity, KYC and AML. New products, adding new products to an exchange where there is very high-performing technology can often be a lengthy and costly process. So you can use the ledger, the templates, to standardize some of those products and bring them into the exchange more quickly. Reference data and corporate action management, anything to do with data, clearly the ledger offers the capacity either to make it more efficient or to have less copies of it, everyone accessing one copy, and to pay less data fees. Securities lifecycle in many different types of securities. And then on collateral optimization and capital. Everyone in the world has to have more capital, and with the new rules, everyone has to post collateral in iterations starting from last September through this coming March, the bilateral margin rules next September, and so on. So making what you've got more efficient, collateral optimization, reweighting a basket of collateral every day for cheapest to deliver, can only be done when you have really good, tight control of the data about the collateral you're holding. Ledger's ideal for that. Creating liquidity. The repo markets are used by some, but not by all. This does democratize, some will be pleased to hear. The cost of the infrastructure to transact repos and then to keep a track of the securities and the cash is high. If that infrastructure is mutualized, then you open up the bilateral repo market. So whereas the first one, optimizing collateral, makes better use of what you've got, extending the bilateral repo market adds liquidity at a time when the market is desperately in need of it. And securities lending and financing is a relatively inefficient and concentrated market where the ledger can bring more efficiencies. So those are the use cases that we're looking at that are not in the public domain, with clients who are still thinking about them and deciding whether or not to bring them to any sort of proof. So this is everything we've done, everything we've said. I'm sure that's on our website somewhere. And if you want to know more, there's a 26-page white paper, the non-technical white paper, that actually doesn't sell digital asset. It talks about the market, the background, confidentiality, obfuscation, encryption, zero-knowledge proofs. It talks about why we've chosen to design the way we have. And if we've got it wrong, someone will tell us and we'll listen. That was released in December. 4,500 downloads so far, so people are keen to learn, which is part of the joy of coming to things like this, that we can still all learn. So, innovation, financial services, and opportunities. Any questions, please?
Gavin, that was great. Thank you very much. Any questions?